Hello everyone. This is the second part of the tutorial series. Let's build a super fast JSON parser from scratch in C#. So in the last video, we built our lecture and we talked about what the lecture does and what is the role of the parser in passing a JSON text. So in this video, we're going to create the parser and we also probably figure out a way to pass out actual objects, like convert our passing output to actual C# objects. So um let's get straight into it. If you have not watched the previous video, please make sure you do that before you come to this. So I open my Visual Studio now. I already opened the project. So I'll create a parser class. So let's create a parser.ps, and it's going to be a public class, and we need a reference to our lecture here. So I'm going to say lecture, okay, and we need a field for the current token. So we already have a token object, which is a record. Um, like I already mentioned, you should make sure you watch the previous video before this one. So we say current token, okay, and we need another field, um, next token. So we need this a sort of look ahead, for to kind of pick which is going to be the next token as we're passing along. So I'll create a constructor here, and my constructor takes just my lecture. It takes the lecture that has already broken our JSON text into tokens. So let's initialize this guy here. Great. So and our current token. So let's start our current token with end of file token. So let's EOF, and the text is, let's say, this, and next token will be new token. Let's say this guy is EOF2, and text is this, the null terminator. And so before we do anything in the constructor, we are going to have a next method. So we're going to have a next method. So let's generate a private for it. Next, okay, good. So we use this next method for for advancing the tokens as we're passing. Advance to the next token. So how does this work? So we just need to set the current token to next token. So we invert them, and to get the next token, we make a lazy call to our lecture to make and to let. So that way is more efficient. We lazily do it like this. It's until next gets called before lecture does something. So then we need the public method that returns an object, just a generic C# object, and this is where the main logic is going to happen. So we call next first to advance from any to just start in a clean slate to advance from any bad tokens and so on. So we call it next, and we check the current token. So let's actually we can use a switch for that. So we can use a switch case. So switch, we have current token dot kind. So okay, good. So if the token kind is a string literal, so token kind dot string literal. We also or if it's token kind dot numeric literal, or is boolean, or token kind is boolean. Um so Yeah, so let's support only string, literal, and numeric literal for now. Um, Actually, we can also have boolean. We can also have boolean. So let's have to do with that later. So what we want to do is we want to just return the current tokens literal. So that is the actual object value. I mean, so in the case where it's a left curly brace, so we know that that is the start of another object. That is, in the case where it's something like this, we know a JSON object, another JSON object is about to start. So we need to make a dictionary like to hold this new JSON object. So if the case is a left curly, or what did I call left curly? Token kind, open curly. Okay, so open curly brace, meaning this guy. So we want to return make dictionary. So this is like our hash map that is going to hold whatever we pass out of the object. So um okay, in a case where it's an open square brace. So open square brace, meaning this guy. mm, so this tells us that we're about to see an array in this JSON. So we have to say make a list, make collection or something. Let's call it make list. So okay, so we'll deal with that later. So now our default case now, our edge case is we can just return maybe an object, maybe an object of well, let me see string dot, let me see. So let's start with make dictionary. So in make dictionary, let's have our output dict equals to new dictionary object, and introduce a while loop. So while our current token dot kind is not equals to the end of that um that open curly brace. So it's not equals to token kind dot open curly brace, right? So we have not so it's not equals to close actually. So close curly brace. So we want to first fetch the key. So key is we call pass again, call pass to just find key. I mean like get key recursively, I guess. So and if the next token kind is not equals to a semicolon, I don't know what we called it. Okay, colon. Let's say colon. It's not equals to a colon. So there's a problem now. Meaning we already have a key. We have a key, but instead of this, there is some other token there, something. So we want to say let's throw new exception, whatever. You can make custom exceptions for yourself, so like expected a colon, found next token later. So and it's fix up shape. So after we do this, we can hit the next to advance to the next token, and then we pass the value. So once we hit the next to go to the next token, and then we pass the value, and we just insert it. So output it, add key and value, and then we move on. We hit the next again. So then after the while loop, then we can just return our dictionary. So similar thing goes for list. So let's come to make list. So output list equals to new list of the C# object. And while we are not at a second, we are not at a close square brace. So meaning we are still inside the scope of that list, of that array integers. So we should keep consuming. So while current token dot kind is not equals to token kind dot close square brace, right? So we want to just add to the object. So we want to say output list dot add and pass it. So whatever is the output of the pass, then we add it to the output list. And then we advance to the next token, and then we return this list. So return output list. So now we have this now. We can easily test it before we move on. So so for us to be able to test that this is working, let's create a class that will make use of our parser, that will use our parser to actually do some JSON parsing. So okay, this is underscore Lexa. How did I have two of them? So okay. So let's create a JSON object class. Let's call it uh let's say our JSON object. Okay, let's call it our JSON object. And so what JSON object does is it takes our parser and then um actually gives us C# objects, C# recognized objects. So we can have the our JSON object class take our JSON string that we are going to pass. So let's create and assign this guy. We can say, because this is compulsory, it's mandatory. So name of our JSON string. So okay, then after we have done that, so inside here we can just say our Alexa is a new Alexa JSON string, and we can say parser is new parser. We pass in our Alexa, and um let's have a field dictionary objects. Let's call it our backing dict. I like to make it very descriptive. So our backing dict, and this is the guy, and we can just say backing dict. So backing dict is going to be let's say parser dot pass, and we just so so we just cast it to a type of dictionary object, since the pass method itself returns just an object. So it may be null. So you can say new dictionary object. So if we don't find anything, so if if not backing date is not, if not backing date dot any, then we can say throw new exception. You can create a custom exception for it. So would not pass JSON string. Pass JSON string. So now we have this. So we can create a method for it, but for now let's just try to even test. Let's try to test it, and before we can flesh it out the more. So so we can have a method that is going to return our backing date. So let's just we can have an interface. I our JSON object. So we can have a we can like return object. Um, we can say get JSON object. Okay, so I will make our class implement this guy, and we tell it to just return back in it. So recall we are still trying, we're just trying to test our implementation is working. So let's come to our program, and I'm going to erase all of this now. So we obviously don't need this again. So since our JSON object has already abstracted what we need to do for lexing and passing altogether. So what we need to do is for JSON object equals to new our JSON object. We'll pass in our JSON string and var values value date, let's call it value date equals JSON object dot get JSON object. So we should have a dictionary inside of this, and we will see if it has the key value pairs of everything in our JSON string. Um so we can console right line this guy to string of it, and yeah. So let's run. So okay, so I see my dictionary has two items. So we have a name, Jason Bond, a key of name, Jason Bond, and a key of age, 42. Okay, great. Nice. So if we do this, so actually, so we can just say each item validate. So we can right line, right line key key value. Okay, like so. Item dot key item dot value. So let's run it again. Okay, and we have key name value Jason Bond, key age value 43. Okay, so our pattern is actually working. So and we are able to get objects out of this. So let's flesh it out the more. So actually I want to add something else to this. So I want to add support for booleans. Um so let's go to our Alexa. So before we do anything else, so let's go to our Alexa. Um we want to add support for booleans. So that we can say something like true, can say something like is active. Let's say is active. I will say true, comma, and then it goes on like that. Uh, yeah. So okay. So to do this, what we need to do since since these booleans are actually going to be seen as a string literals too. So so we are going to have to create like a different kind of token for them as as boolean literal or something. So let's first start with adding a new token to say boolean literal or something. So good. And and to do that now, so we have to make the Alexa recognize them specially. So let's create a new. So if when we are passing for string literal, so where we are passing for string literal, where we are passing for string literal, so we we have to um so actually let me do if so else if current char um equals, or let's say um so let's just say I'm looking for an efficient way of doing this. So let's say else if current char is t, let's say t, or current char equals f. So that is true or false. So we want to say like return make boolean literal. So so let's make this one change, and then we can go ahead to create an actual way for a way for us to deserialize into C# objects using our parser. So we do the same thing, similar things that we did in the string literal. So we take what is in current pos. So current pos is position, and why current char is not equals to end line, that is not terminator, and current char is not equals to e. I know there's probably some more efficient way of doing this, but let's go with this for now. So since both true and false and with e, uh, so let's hit next, meaning we should go to the next character. So then bool value is the actual literal substring current post position minus current post plus one. Did I call it current position, whatever. So this will actually give us true or false the word. Then we can return new token. The token kind is boolean literal, and then we say like bool dot pass. So bool dot pass bool value dot to string, whatever, and then okay. So now our Alexa will recognize true or false now. So let's come back to program. Let's come back to program and see if that's if it gives us this active. So all right. So okay. This active value is nothing. So yeah, we have to make the same change in. So we have to make the same change in our parser. So let's come back to our parser. So So for here, so we want to say case token kind boolean literal. Okay, good. Okay, good. Let's try again now. Let's run it again. And, and then we have true. Bravo, this works. So now let's create a sophisticated way of actually deserializing this stuff. Uh, because if we even okay before that, let's try to see if if we had a nested object. So nested object, if it still does its work as it should. So let's say nested object key, or let's say nested object, let's call it time, or like ID. Yeah, ID is one, and ID item number item number is let's say item number is a string also. So let's say 123 AB. Okay, and so this is a nested object. So let's see if our dictionary if it's able to catch up. So obviously for this nested object, uh we might be able to get the key when we are printing to the console. We'll be able to get the key, but the value it might just call it to string. But is another dictionary. So is another we might be able to get this key nested object, but this value, which is another object on its own. Oh, there's an error here. Another object, so it might just give us to string. So that is why we need a more like a clearer way to actually pass them out into objects, to nested objects. And I'm going to show you how we can get that done. We'll use reflections. So but let me just run it first and see. So obviously we have the key, like I said, yeah, we have the key nested object, but since the value is a dictionary also, so we need a sort of a recursive way of printing it out. So we really don't need to do that. So let's just go ahead and create a way for us to deserialize it easily onto any kind of object. So we are going to do that inside our JSON object. Let me give you the idea. Um, so in Java, most times when I write Java, there's something called I think J object. So there's a J object class. Um, see, okay, this is in C sharp. There's a JSON object class, and so it's used for, like serializing JSON into actual um hash map, like dictionary like objects like this. So we are going to have something similar. So let's say new JSON object, new JSON C sharp object will be something like our JSON object dot get JSON objects, and such that it will be generic, that we can pass any generic parameter, and it will get it for us. We can even pass a key, and it will be able to fetch it for us. So let's do that now. So I come to our JSON object. So we either need a new get JSON object, or we can modify the same one. So let me see. I think we should modify the same one. So let's modify this guy to return a generic type T, and I think it might need a key. Let's say string key. and we want to give some constraints. So where T can be class or new. So T get JSON object T. Okay. So we obviously need to implement this new change. So we modify this guy to look exactly as it should be. So where T can be a class or an object. So all right. So let's see. Okay. So the thought process here is we need to look for a way to pass through each key value in our JSON and be able to use our use our what our parser has generated, be able to use that to form C# types, classes, class or whatever objects as we want. So this is basically what this realization means. So um so first we if if no key is passed, so let's have an assumption that the individual is trying to get everything in the tree. That is, you are trying to get everything in the past tree, meaning you are trying to get all of these things. But if you pass a particular key, say name or this nested object, so we assume you are trying to get only nested objects. So how can we achieve that? So let's go. Let's implement that logic. So dictionary object objects, and let's start with our value. Let's say value. So if string is null or white space, that is if our key is null or white space, so we know that you are trying to get everything in the past tree. But else maybe what you are trying to do is just get one of them. Okay, and we say backing the key. I know that might be my backing problem. So and so we now need to so our main logic to convert this our output, this dictionary object into C# types. So we are going to create that. So let's say private C, or let's can we make it static? So let's say private static T or void. Yeah, I'm going to be using references. So add dictionary to object, and we're passing the T, or let's say results. So this is the reference to what the output of this method will be. So and then our input is whatever dictionary we arrive at from here. So dictionary, and we add the constraints where T is a class or it could be an object. So okay, so inside here it is expected we're going to call so T results equals to new T, and we can convert dictionary to object type of T. We pass in the result as a reference, and then we pass our dictionary that holds each key value in our past tree. So so value, and that should okay. and then we're expected to return this afterwards. So, so if dictionary, so let's start the logic for this. So if dictionary or any, we are going to do all of this if dictionary or any, or let's do a an early return. So if not dictionary or any, so so let's just return the let's just return just like that, and then we can do everything else here. So so we want to start by going through the dictionary, and we can just say for each verb um KVP in dictionary. So we get the property. So we go through the dictionary that is formed from this, and we get the property, the key here. We get each key, and we try to get the property in the type T that we are given. Meaning, if we have a class, so actually let's create a class for this guy. So let's call it sample JSON object. So sample JSON object. So let's say it's public, and let's say it has a public string name. Okay, and what else is there? What else is there? It has a boolean. It's active. Actually, I can bring this open here. So we have a name. We have so let's say come on, no. So we have a public boolean is active, and then we have a public nested object, nested objects, nested object. Okay, so let's say nested object is here, and it has a public in ID, and and what other property was here? Okay, we have a public string item number. Okay, so after nested object, we have age. So we have a public int age. So this is new. All right, good. So we're going to go through the output dictionary one one key at a time, and we look for the property that is having the same key in the type T, the generic type that we're passed, and we fill them. So I'm just trying to explain the logic of our implementation. So get the property, get prop. So our property is going to be result. So result of get type. So that's where I think this is where we come to this is where we come to having intermediate knowledge of C sharp, like generic. So we need to get a key. So we need to get key, call it to string on it, and so or string or empty to get rid of these stringy lines. And after we get the property, so if property is not null, so if property is not equals to null, so we need to and it's a writable property, like it's not a read-only or something. So we need to also be mindful of that. So and yeah, we go on. So before we go on, we also check if we also check if the type of property is a list. So there's something else we have to do. So we have to check, is property a list? We have to check if it's a list. Is property a class? A class, a nested object. So we have to be sure that that is not a class or a nested object. So what we should do is so check so if property dot property type dot is class, okay, and property hold on, property dot property type, okay, is not equals to type of string. So okay, okay. So let's put an S here. So if it's a class, so it's a nested object. So we also need to check, could it be a list? Could it be a list type? Meaning could it be something like this? Let's say I enumerable or I list or something. So that is what that means. So we want to say if property or property type dot is generic. So this is to check if it's a generic type, and property type dot gets generic type definition equals to, so this is where we find out exactly if it's a type of list. So okay, so if it's a list, so then that is something for us to handle. So let's get the generic argument type. So we get the argument type, meaning we want to get the actual list type, meaning if there was a list here, so we want to get nested object type. So that is what that means. So let's go on. So common property type gets generic arguments, and we want to get first, let's say first or default. Okay, and list type is type of list dot make a generic type of this guy. So well, I don't expect you to understand this. I don't know, but I mean, I think you can have a look at the code. So meaning we are trying to instantiate the list type of nested object. That is, we're trying to say new list nested object, but using generics this time. So sorry. Okay. So activator, can use activator for that. So list type. So the next thing we do, we save list data. The data we actually want to fill into the list type. So is the value of this guy, kvp dot value, which is a nested object. So we say kvp dot value as a list, see it as a list object. And so if list data is not equals to null, so what we should do is to iterate through for item. I say item in list data. So and then so if it's another class, if it's another class, we also have to find out if the items inside the list type do we have another class here? Maybe my class. So it's uh it's intertwined somehow. So if so if generic argument type is a class, actually this is knowing if the nested object is class. Else is it something like a list int, or is it list anything else that is not a class? So int string anything else. So if it's class, so then we need to get the nested object. So get the nested object. So activator dot create instance. Then we pass in the generic argument type. And then we recursively call this whole method on it. So because the essence of this whole method is to do it on a class type, on a complex object. So I mean like reference type kind of. So we call convert dictionary to object. I'll pass in the nested object. I will say we pass in the list item as a dictionary of object, and then we add it to nested list. So um so did we call it nested list? Oh yeah, this should be a line list. User systems collection. So nested list of that. So we add nested object. Okay, so the else case now, meaning we have like primitives, a list of primitives or something. So over converted list item equals to, then we actually now set the values now. So change type item and the generic. So we convert the types, we change and set we change the type actually. So and nested list dot add converted. Oh no, this is right, converted list item. So once we have done this, we have been able to undo this. So we can now say property set value results nested list. So our else now, meaning if it's not a generic type. So if it's not a generic type, it's just a same simple object. So we say nested object equals activator. We do similar thing that we did. So property dot property type property type. So then nested data equals kvp dot value as a dictionary of object. So if nested data is not equals to null, so we want to nested data is not equals to null, so we want to recursively call this method that we are currently in. So nested object, and we pass in the nested data. So nested data And once we have done that, we can now set the value. So property dot set value result left limited. So and then we handle the else of if it's a class and it's not type of string. So meaning it's just a normal property, meaning handle for things like it's active age like that. So for converted value is convert and string type. So we do the same. So kvp dot value and property dot property type. And then we simply just do property dot set value and we set the value of result as converted value. And we are good. So we are fine. So let's try to test this out. Um, so definitely our get JSON object. Um, so just let me first get rid of this. So our get JSON object we now have so we have instantiated it here. So then let's say sample object. So sample object will be JSON object dot get JSON object. I will pass in the type. So sample JSON object. And let's assume we are trying to get everything. So like I said, we pass an empty string to get everything in the pass string. So and let's implement a to string for this so we can see everything. Okay, override to string means so string the format name is active nested object and age is active nested object age. So we do a to string for nested object too. So okay, so we say okay, so ID 010 ID item number 1 and we say ID item number. All right, good. So let's just say console write line past let's say JSON past into C# object is this guy sample object. All right, good. Let's try to run now. And all right, bravo. Name is active, nested object. And if I over this guy, so we have a sample object. And guys, that's it. We have been able to create new things of the game. So as you can see, it deserializes and the types are good. So let's see how it will handle a list. So let's add something else. So let's say var items. So let's add items. Let's add a list. So let's start with just a list of primitives. Let's say list items. Let's say one, 1, 2, 3, 4, 5. So a list of things. So let's update our guy now. So public list int items name list, name list actually. So let's run it again. Actually, I need items. Items, items. So give this for, give this three, give this four. Items. So let's try to run it again. Hold on. So good. So there should be a semicolon somewhere, and I've broken the JSON. Yeah, so it should be a comma here after the list items. So bravo. Items. So items is currently displaying as okay. So the to string for it is not okay. So but we have five items. Bravo is working. We have five items. So that works too. So what if we have a what if we I mean if we had a list of nested objects? If we had a list of nested objects, let's see. Let's see nested objects. And we have this guy and we let it have two of them, two of nested objects, two of nested objects, ID two 1149 AB. Okay, and let's update our sample JSON to two of nested objects. Public list nested objects. Let's call it nested objects. Okay, okay, good. So let's run again. Let's run it again and bravo items. Okay, and you come here. You see we have items 5 ints and nested object is this, and we have a we have a nested objects, and it's having two items. One this. So this will bring us to the end of this tutorial. I think it's been a wonderful time. Uh, Thank you for watching. If you like this video, um, please like and subscribe and share it to people in your network. And thank you very much. I'm going to put the code on my GitHub, and there will be a link in the description for it. So thank you and see you in the next one.